a pretty special place. I know a lot of people from the rest of the country would say they're tiny because they're the highest peak here. Washington's only 6,000 feet, but it's classified as having the worst weather in the world, and it has had the highest recorded wind value. So the snow blowing and the wind, avalanches, and part of all of the fun of it is making the right decisions and enjoying yourself being out in nature, if you're prepared for it. But if you're not, I mean, it's killed 102 people, so you need to use your wits and be careful and know when to turn back. Deb and I are going to head up into Tucson. We're going to do the Tuckerman's Waterfall today.
Even Rob would agree that knowing when to turn back is a lesson he learned the hard way. Halfway up Africa's tallest mountain, Kilimanjaro.
Back in 1978, I got this notion, just from a single picture of a friend of mine had, that there was a side of Kilimanjaro no one had ever climbed. And so in youth, one often does wild things, and I got the idea to go to this face, which is capped by this enormous 300-foot icicle, and we'd climb it. And things went actually quite well, up to 12, 13,000 feet vertical, the whole climb, until we got to the icicle, and when we arrived, the temperature was above freezing, it was melting. I made a mistake, and I went onto the icicle and climbed it. It got into a situation where it was just like oatmeal slapped onto a wall at home, a little child might throw. And no matter what I touched, it just started crumbling and falling away. And after some yards of making my way up, the ice above me and right directly in front of me broke off. Hit me in the face. I flipped over backwards, came straight down through the air, and actually smashed into the ledge, but kept going as I bounced off. Finally, I ended up at the end of the rope, and it pulled up taut. I looked through my legs, and there was the jungles of Africa, 18,000 feet below. Then I looked down and realized that something was dramatically amiss, because instead of seeing the top of my bootlaces, my foot was turned 180 degrees around, upside down, so that the actual sole and the climbing spikes were facing upwards.
His climbing partner was below, anchoring the rope. Rob was lowered to the relative safety of a mountain ledge where he first assessed the damage.
I took my glove off and started to push my hand down into this area here, and discovered not only had the outer leg bone, in fact, broken the skin here, but in fact was sticking out about 6 inches over the top of my boot. And I looked at the blood in my hand and realized I was in bad trouble this time.
Somehow, Rob pushed the bone back in line and staunched the bleeding with bits of cloth. But inside his body, the battle was just beginning. Blood platelets rushed to the site of the injury and knit a web around the damaged cells. Eventually, the bleeding stopped. But the body's first line of defense, the skin, was broken. Bacteria flooded in, quickly multiplying their number to become an invading army bent on destruction. Poisons from the bacteria bombard and destroy the tissues closest to them. Because the body's chemistry is subtly altered, news of the attack travels fast. The counterattack is on. Leaving the bloodstream through tiny spaces and capillary walls, the phagocytes are first on the scene. These roving patrol squads carry powerful poisons for instant attacks. More often, they engulf and devour their opponent whole. In this real-life footage, phagocytes are attacking and swallowing up bacteria. And here, the phagocytes are gathering to do battle with a deadly foe, an asbestos fiber caught in the lungs. The phagocytes, In fact, our entire immune system is created from cells that originate in the body's munitions factory, the bone marrow. Within the marrow, stem cells divide and grow in different ways to form our many defensive weapons. Some are sent to the thymus for further development, and some grow to maturity here inside the bones, like the cells that grew into platelets and stopped the bleeding in Rob Taylor's leg.
I took the leg and discovered by tying it up to the back of my harness, I'd pull it under tension, and then I used my good leg, this one, to go backwards downhill. So in fact, that way I hopped with my 2 arms and ice axes and the one good leg backwards over the next 3 days. Slowly but surely we made our way. We then decided that my partner would go down to the Shaga village, the tribe that lives at the base of Kilimanjaro, and get them to come up and help me get down. I got in my sleeping bag, my partner packed up, head off, and I waited for him to return with help. He didn't come back in a day. I actually didn't expect him to. It was a great distance to cover. But then it got into the second day and the second night, and I started to get nervous because it started to snow. And that snowstorm turned into a blizzard. Into the third afternoon, I'd been waiting for day after day for help to come, and it just became clear that it wasn't going to. Without food, you last for months. With the blood loss, unfortunately, though, that I'd had, and the infection that very slowly was starting, but most importantly, without water, it just came down to accepting the fact and facing that this time I was going to die, and there was nothing I was going to be able to do about it. It was not so much accepting it, but as, imagine you walk down a hole and you arrive at the end, and that's death. I was lying there in the snow, the sheets of snow running across, and there, out of the snow, 6 Shaga tribesmen and a blonde Norwegian rescue. But to think of so many miles being able to be moved, it seemed impossible. The Shagas had an easy answer, and that was that they would pick me up and carry me on their backs, which they did day after day. Just about the most extraordinary human beings I've ever seen.
The rescue team brought Rob down the mountain. But as the elevation dropped and temperature grew warmer, the infection in Rob's leg grew worse. The enemy began to overwhelm the body's defenses. With any infection, the phagocytes are the first to fight back. But often they can't do the job alone. If the invading forces are too overwhelming, the phagocytes will keep eating until they burst. The remains of this battle are part of what makes pus. As wave after wave of phagocytes fight and die, the heavy artillery comes into play. The large and unwieldy white blood cells called macrophages. These are basically giant phagocytes. Like naval forces, macrophages are stationed in large numbers at strategic locations around the body. They capture the bacteria by lassoing them with protoplasm. The macrophage envelops the invader and breaks it into small pieces. Here is what an actual macrophage battle looks like.
When we finally got down to the base, I was sweltering. It was about 100 degrees, even though it was the middle of the night. The doc came out from the hospital, and he just sliced the trouser leg off. Then I looked down, and for the first time, got to actually see the leg, which I hadn't seen for nearly a week, and the kneecap was gray-purple. The toes had gone totally black, and this thing now was completely involved in gangrene. And he looked at me directly in the eye and was matter of fact and said, "This leg has had it. I'm taking you into surgery, and I'm taking it off 8 inches above the knee." I obviously said there must be something you can do, and argued back and forth and pleaded and then prayed, and he made it perfectly clear, it was black and white, that he would give me 24 hours leeway. And if that 24-hour allowance would give me better feelings, but he knew the end result was going to arrive at the need to amputate the leg.
Rob was fighting a war against hundreds of different bacteria. The massive invasion was too much for the simple defense offered by the macrophages. Rob needed the experts, T cells that could identify different strains of invader, and B cells that could engineer antibodies, the specific weapons to fight them. The thymus, a small organ located between the lungs and above the heart, plays a pivotal role in the body's amazing ability to recognize an enemy. From before birth through puberty, large numbers of the same stem cells that gave rise to platelets, phagocytes, and macrophages migrate from the marrow inside the bone to the thymus. There they receive a higher education. Thymus cells, T cells for short, stay here for years, packed like sardines, learning the art of self-defense. Exactly what goes on here is a mystery. But somehow, the T cells learn how to tell the difference between friend and foe, cells that belong to the body and those that do not. T cells are specialists. Each type learns to recognize a different group of invaders. When graduates of the Thymus Training School are released, they immediately begin to patrol the body, searching out any suspicious-looking cell. Here, killer T cells check out a body cell that may have been infected by a virus. If an infection is found, they will destroy the cell. In the case of an all-out attack like the one on Rob's leg, a helper T cell docks with a macrophage. The macrophage presents bits of the invader for the T cell to analyze. This is what it looks like in real life. If the T cell can recognize the piece of the invader, it sends the word out. A nearby B cell, which can also recognize the invader, receives the message. Hormones activate, causing the B cell to divide and to begin to produce antibodies of exactly the right type. An antibody is a Y-shaped missile made of protein. The tip is the same in all, but the two tail fins on the bottom are custom built to match the protein structure of the invader exactly. It locks onto the enemy, robbing it of its ability to harm. The body never forgets an enemy, building up its repertoire of antibodies over the years. Familiar invaders are fought off quickly, but Rob Taylor was fighting the microbes of Kilimanjaro, foes his body had never seen before. B cells can engineer antibodies to fit virtually anything. The question is whether the right antibodies will be produced in time to fight the growing infection. How the body is able to manufacture precisely the right antibody to match every new kind of invading organism is one of the miracles and mysteries of the universe within. Neutralized by the antibodies, the enemy bacteria is finished off by the phagocytes. But this process can take several days under the best of conditions. For Rob Taylor, conditions were the worst. The hospital was out of antibiotics. With 24 hours to save the leg, Rob's doctor had one hope.
His thought was to use a technique from the 1800s, using painkillers in the lower leg. He bore 6 holes straight through the ankle joint and then put pipes through and began to attach garden hoses, and he ran hundreds of gallons of water through the 3 sets of hoses to try and move germs away by washing. 24 hours later, he actually had seen improvement in the lower leg and decided day by day that he would watch, and if he could delay the amputation, he would. 6 weeks later, the leg was still attached, and he would call it a miracle. I would call it obviously that and a bit more, because the Chagas obviously did some pretty amazing things to save my life.
It took Rob Taylor 3 years to rid himself of the last of 300 microbial infections. It was 5 years before he began to climb again, 10 before he felt really good. He returned to Kilimanjaro in 1985, completing the climb he had begun so long ago. This time, his partners were the Chaga tribesmen who had rescued him. Today, he climbs as much as ever, but with a different perspective.
I've come to appreciate over the years that when you take something for granted, and I mean walking or climbing, and I certainly climbed for years and enjoyed it, but then when it's taken away and you are given the gift back, each and every time I put the foot down onto the floor and walk, or I'm back onto climbing, I begin to realize the sheer joy that it gives me.
Speed skating. The power, the grace, the controlled 30-mile-an-hour sprints around the track are the result of an unending series of demanding workouts. Here in Milwaukee, the United States speed skating team is preparing for another grueling season of competition. For 5-time Olympic gold medalist Bonnie Blair, it will be the last.
I'm definitely looking forward to the World Championships here in Milwaukee, you know, kind of my own home turf. Also, I feel that being able to kind of finish up at home is going to be a nice feeling. My whole family's going to be here, friends. I don't know how many they're expecting this time, so I'm definitely looking forward to it.
Team training involves weightlifting. Torturous set of isolation exercises called plyometrics. And every other day, they spend the afternoon running up hills. All this activity takes a lot of energy. And at 5'4" and 130 pounds, Bonnie is hardly superhuman. So what's the secret of all that record-setting speed? Is she on a special diet? Space-age formula of vitamins and proteins?
One thing that people have kind of always teased me about is usually day competitions, I always have a peanut butter and jelly sandwich. And, you know, that's just been something that's worked well for me. I enjoy that. That's probably one of my favorite lunch foods anyway. So, you know, when you are at a competition, sure, you're going to have some nerves. And so you have to find something that's going to sit well with you in your stomach. And that's important. And to me, a peanut butter and jelly sandwich is what works best.
For a jolt of energy, there's nothing quite like the sugar and carbohydrates in Bonnie's snack. They're very close in structure to the fuel the body uses, glucose. But a quick fix will only last about 20 minutes. To make it through her day, Bonnie needs a huge amount of energy, stockpiled for use a little at a time. The way the human body manages this is to convert everything we eat into a few basic components: instant and storable energy, vitamins, nutrients, and waste. In a process never to be discussed at the dinner table, here's what happens after we chow down. The first stage of digestion is simple. Moistened by the saliva of the mouth, muscle contractions move the food down the gullet toward the stomach. Here,